Hi friends, Tyler here again. Today we're going to be looking at Rust fuzzing for Soroban contracts. Pretty fun word, doesn't make a lot of sense on its own. What is fuzzing? Well, essentially when you're testing a contract, let's look here at the code. I've got a really basic contract here that literally does nothing except say hello. It takes in an argument of A and B, which are I-128ths. And it just returns a vector of those. So probably the most boring contract you've ever seen in your life. And normally you'd write a contract and then you'd just go and you'd test it, right? So write a quick test, instantiate your contract. I'm setting up some ledger variables because you can do that. And then you would call your client, hello, pass it in those I-128ths. In this case, I'm doing a min and a max. And that would be how you would test your contract. You just pick some arbitrary values, but they are singular values. You just test this one time, and you might write a couple different tests that would test for a couple different specific states for your contract. But this is always going to be a slightly problematic in that, are you really sure? Like, what happens if this was 1 or 2 or 3 or 4? What if this was 4 and this was 6 and this was 12 and this was 9? In this case, obviously, the range of what could happen is very minimal. Nothing crazy is probably going to happen, but the concept of fuzzing is, let's just test everything. Let's take in the arguments. In this case, they're coming from this input struct, and let's just test a bunch of terribly random ranges of things and just stuff them all in to whatever our test is. And just test it over and over and over and over again with a bunch of random values. Why is it called fuzzing? I don't know. Maybe stuffing was already taken, so they just picked fuzz instead of stuff. I'm not sure. Regardless, though, the point is this is a really cool way to test your contracts for errors that you probably otherwise wouldn't catch by just testing lots and lots of random values. So in this particular example, again, our contract is very basic. Cargo has some nice tooling available, a crate for fuzzing. So you install that. There's a really nice Soroban stellar.org document in the advanced tutorials on fuzz testing. So this is where I'm getting most of my information about creating fuzz tests and how to interpret them. So I am only as smart as this documentation is myself. So definitely go and check that out for to kind of fill in between the lines of things that I won't cover in this video. Yeah, I've got a fuzz test. There's a directory that it creates. It's actually its own crate here. A fuzz directory. I've got a fuzz test. It automatically sets up a fuzz test for me. I've gone ahead and filled all of this in, and it's essentially just copying the test we have right here, but putting it into a fuzz test. So essentially what this is going to do is use this input struct, and you'll open up this fuzz target. It'll pass in input, and this is what's just going to be looping endlessly for all of eternity until you stop it. Stuffing all of these inputs. So instead of having static values, these are arguments that come from the input, A and B, which are I-128ths from before. It puts those in, and then it asserts. It just makes a quick assert to see if what we put in is what we got out. So if you'll remember from here, we just take A and B, and we return A and B. So it's just looking to make a quick assertion. Again, a useless test for a useless contract, but hopefully will serve the point of explaining a little bit on fuzz testing. So anyway, to run this test, we need to use the nightly version of Cargo. So we'll have Cargo, nightly, fuzz, run, and then our fuzz target. And because I'm on Mac, I actually need to use sanitizer thread. This is called out in the documentation. If you're using Linux or Windows or something, you might not need to use sanitizer thread. You can use sanitizer address. I have no idea what a sanitizer is or what it does or why it needs to be thread for Mac. I just know that if you don't do this, it don't work. If you do, it does. So that's how I program. So we'll go ahead and run this. And essentially what it's going to do is just run against our library or the contract that we're pulling in and just start stuffing all of these values in. You'll see the coverage that we've tested. I think this would be the number of executions that we've covered per second. So this is the amount of different variants we've been testing every second. I'm not terribly experienced in what all of these things mean or what an RSS feed is that's 78 megabytes. I assume that's not what that stands for. But again, regardless, what's happening here is it's just looping over, sending out all kinds of different values for A and B as it goes through bunches and bunches of fuzz. So we can just let this run. We know that this probably is never going to error because it's such a simple contract. So I'm going to go ahead and kill this. And I'm going to introduce, on purpose, the potential for bugs. Or not bugs, but errors. So I'm going to say if A is 7 or if B is 7. We'll just panic. Go ahead and save that. And again, the only way we would trigger this in a test is if one of these, instead of being min and max, unless one of these was 7, this is always going to succeed. So if we run a test here, we'll notice that it passes. So we might think, sweet, we've written a perfect contract, never realizing that if we ever passed a 7, it would crash. Let's go back to our fuzz test, and we'll run this again. One thing that I'd like to call out that is not called out in the docs is if you're using Rust Analyzer, so I've got VS Code set up, and then I have Rust Analyzer installed. This provides you, so when you hover over things inside your code, you'll notice I'm getting some nice outputs from stuff. If I go and I do something like env, I see what all env can do. This is a very helpful tool as you write contracts. If I pass in something that doesn't exist, like Bob, it's going to tell me that Bob does not exist, and maybe I can import Bob, who knows, or I've got Copilot installed, so I could maybe get Copilot to fix the absence of Bob. But on our fuzz targets, we're not getting any helpful outputs, and that's because by default, VS Code is not picking up this fuzz targets because it's not included in the source. It's not coming from our cargo toml here. So there may be a better way to do this by including it in the toml or something. I don't know. I'm no Rust expert. The way that I've solved it is by including it in my settings. So Rust Analyzer has this Rust Analyzer linked projects, and then you can basically say go into the fuzz directory and pull in the cargo toml. If you only include that, now it won't Rust Analyzer won't automatically pull in the cargo toml. So now our normal project will be missing all of its useful help. So we need to then manually add in any other additional crates that we'd like to have that analyzed. So we'll add that, and then we'll notice back in our, once this finishes analyzing, when we hover over stuff, loading, it should start helping us out with code completion. Might need to restart your server. And then when we go back here, and now if we were to, for example, put in Bob in our fuzz target, we'll notice that Rust Analyzer is now properly indexing and delivering helpful responses in our fuzz target. Fantastic. Well, let's go ahead and rerun this. Now that we've added in some panic conditions, let's see if fuzz ever hits either one of those 7s by its random smattering of bunches and bunches of numbers. Again, the I-127 is a very large numerical value, so it could take a while for it to eventually hit either a 7 on the A or the B. So I'll just let this run, and we'll see if we hit it. Keep an eye on my shirt. Do I change? Do I grow a beard? By the magic of video editing, how long did this take? All right, we've hit an error. We can see that B was a 7 and A was not. My goodness, this is my bank account number right there. Yeah. Okay, so we had a 7, so this is what a fuzz error looks like. It's got all kinds of gibberish, but at the very end is quite helpful. And the most helpful bit here is how to rerun to always hit this target. So if we were to save, you'll notice it doesn't include nightlies, or I think oh no, it does include sanitizer thread. That's nice. So you can rerun this test. We'll just need to make sure we include nightly. We'll notice that we'll hit that error again, which is great because now you can go and try and fix your error, which will remember this was B. So if we just comment that out, save it, and rerun, we should pass against that exact same error condition or seeded error. So there we go. We passed the test, did an error this time. Wonderful. So if we were debugging our code, we could rerun this test until we fixed that particular error. In our case, if B is a 7, throw. So we'll go ahead and keep that, though, for now. All right, so that is the basics of fuzzing. Obviously, the Soroban docs have a lot more helpful information around more complex tests, but I think it's helpful to kind of see your base, bare minimum, how to configure one of these. It's actually very simple. There are some really helpful things we'll get into in just a moment when we go to the Soroban example fuzz tests and how to actually patch one of those. But that is fuzz testing in a nutshell. Let's go to prop testing. So this is like after you've done a bunch of fuzz testing and you've kind of fixed all the big bugs, you can then go add a prop test to avoid regression errors. So like as you're continuing to build out your contract, or maybe there's a big update or something, rather than going back and doing all your fuzz testing again, you could just keep a prop test inside your actual project. So one of the nice things about prop tests is you can run them just as normal Rust tests. You don't have to create a whole nother fuzz directory and a whole new crate. You can call them same as you would a normal test. But inside prop test, very similar to the way that you do it with a fuzz test, you set up a prop test. You tell it the number of cases or the number of loops you want to do. You've got the same sort of input thing. It comes as an arbitrary input, similar A and B. So those are going to be our I-128s again. And we can run this test. Now, again, this is only going to loop over 10,000 times. I-128s are a little bigger than that. So my guess is if you run this test, we're not actually going to hit that error unless you just, by some miracle, with only 10,000 tries, you hit one of these I-128s as a 7. So again, maybe at some point you run this 1 trillion times, you would hit a 7. Or you just are very good with chance. Which again, this is one of the reasons I think that demonstrates why fuzz tests are so powerful, is they're able to loop over at incredible rates of speed all of the different variables to eventually hit, relatively quickly, considering one of those values of A or B being a 7. You can change this number to wherever you want, but again, once we've patched off of a fuzz, the idea would be that this probably is going to be fine. But keeping both is a good idea. I do like with the prop tests, you can run it just as a normal test inside of your lib. There's no reason or no need to add additional things for Rust Analyzer. You just include it as a mod on your actual contract, same as you would a normal test. So that's cool. Looks very similar, behaves very similar. The Soroban docs cover prop tests as well. So sweet. All right, so let's go to one more thing. One more thing on the Soroban examples. I'm going to pull up their fuzz example. So I've got all these different example contracts, and they've got this fuzz directory. And so if we open up a terminal window here and we run the exact same thing, you'll notice I'm going to call this target 1. So this one's running off of some, I don't even remember, contract, I think like a time lock or something. Yeah, the time lock contract is what it's pulling in, and it's running a whole collection of tests, fuzz tests against that contract. We'll call it the exact same way. We need to cd into the fuzzing directory before we call that. And so this will stand up and run the fuzz tests. against that contract, but I think pretty quickly we should hit an error. And that'll spit out. And we can see that our deposit amount is 0, which it should not be allowed to be, right? When you're doing, I think inside of the time lock contract, there is logic that says if you're depositing nothing, that's an error. You shouldn't be able to deposit nothing. So this isn't an error in the contract. This is really an error in our fuzz test, where we already know the contract it's valid. Deposit amount should throw, but we want our fuzz test to bypass that. So we need to modify our actual fuzz test a bit so that our deposit amount, even though it is a 128, 0 shouldn't be allowed. And in fact, you shouldn't be able to deposit negative numbers either. So maybe this should have been a U128. But regardless, what we need to do here is basically tell the fuzzer to start at 1 and increase and not allow 0 or negative numbers. And if you go to the fuzz target 2, this is a more complex example. You can see these like describers that go above, and here's one that's very helpful. This arbitrary unstructured, use this range. This is kind of the one we're going to use. We'll just modify it a little bit. So in above deposit amount, we want it to be greater than 1 and either and all the way up to and including, so inclusive of 128 max, right? So start at 1, not 0, and then go all the way through to the max of the I-128s. And that will ensure that deposit amount is in that range. We'll also notice that we're not getting any helpful outputs. Unstructured is actually unimported right now, and so this should be getting a nice little red squiggly wiggly, but it's not, and that's because our Rust analyzer isn't picking this up yet. So I'm going to modify the VS Code. Now I'm going to tell you right now, Soroban examples has loads and loads and loads. Like every single one of these has a cargo toml. And I am not going to go through the process of adding all of those manually. They pick them up automatically by the magic of Rust Analyzer. But when we have a value in here, I don't know if the linked projects array takes in like star values or something. But for our purposes right now, I want to show this as having a red squiggle. And so there it is. This will hopefully have a quick fix for us in a moment, which we can then import the unstructured. Let me just go ahead and restart. There it is, import lib fuzzer unstructured. Save that, bada bada bing. We'll rerun this. And we shouldn't get that 0 error, and this should begin to hit all of the coverage points. You can see this coverage is beginning to increase as we test out all of the different various branches, which is beautiful. So yeah, that would be a way to kind of tell the input there, don't just use any I-128, restrict it to just this range. And if you go to the example 2 here, there's quite a few instances of this being used for mostly I-128s. There's one for U64. There's a U-size one. This one actually modifies off of a vector, which is quite complex. And then another U-size. So cool. And this just keeps on running. So that is Rust fuzzing in a nutshell for Soroban contracts. Hope that was helpful. Strongly encourage the use of fuzz testing on your Soroban contracts. Soroban's made it very easy. This is a differentiator of Soroban smart contracts. This does not exist on every smart contract platform. It's some unique benefits for the way that Soroban was built, and it's just going to help so much in avoiding a lot of common errors by just trying everything that could possibly go wrong in a contract and then working your way back through those errors to make your contracts rock solid. Be sure and join the Stellar Developers Discord as you have questions. Read the Soroban docs, and I'm sure you'll see me in another one. Catch you later.